We have seen how the probability that xy is in some particular set S can be equated with a volume of the tent under the density, joint density standing over that S. Now, since volume is a geometric object, so using just geometric considerations, we can be able to find out the probability in certain simple cases. But if this function is complicated or this shape is rather irregular, in that case, we have to use iterated integral. So I am going to show one example of that. So xy has joint density fxy, which is given by x plus y if xy lies in the unit square. You can easily check that this is really a density because the total volume is 1. The question is, what is the probability that y will be less than or equal to x squared? So for such a problem, it's a good idea to draw a diagram of the xy plane. From this condition, you can see that the entire drama is being played in the unit square. Now this particular region, y is less than or equal to x squared, is this shape where this is the graph of y equal to x squared. So you have to imagine that I have the surface x plus y, which is basically a plane, floating above the xy plane, and I am creating a tent with this as the floor and reaching all the way up to the surface, and I have to find out the volume of that. It is not a regular geometric shape for which I have a ready-made formula, so I have to use iterated integral. I start by writing the two integrals and this x plus y thing. Now I have to decide whether I want to do with respect to x first or with respect to y first. Suppose I decide to do it with respect to x first. So the outer integral, when you write down the limits, you have to start from the outer integral, that is with respect to y. Y goes from 0 to 1. 0 to 1. Once you fix a value of y, x goes from how much? Root y to 1. Root y to 1. So I have reduced it to an iterated integral. Now I can proceed mathematically. In the first step, I am doing the inner integral. X is what I am integrating with respect to, so it becomes half x squared. Y behaves like a constant, so it becomes xy. And I have this two endpoints. When I put 1 here, remember I am putting x equal to 1 here. This becomes half and this becomes y. Then I put x equal to root y here. So this becomes y by 2. And this becomes y to the power 3 by 2. And now it is a simple integration which you can finish yourself. Now if you want, you can actually do it the other way around. First with respect to y and then with respect to x, and check if the answer turns out to be the same. So this is the same problem, but now I want you to do it the other way around. First y and then x. You have to put the appropriate endpoints and then work out. Hopefully you should get the same answer. If not, there is something wrong.